What happens to the human body when you live in space for a full year? In 2015, NASA launched a radical experiment. They sent one twin, Scott Kelly, into space for 340 days, while his identical brother, Mark Kelly, remained on Earth. Same DNA, different planets. One groundbreaking mission to find out how space changes the human body. Scott Kelly wasn't just going to the International Space Station. He was becoming a living science experiment because he had something no other astronaut did, an identical twin on Earth. This gave NASA a perfect control subject to compare with. Two genetically identical bodies, one in space, one on Earth. Let the experiment begin. After just a few weeks in space, Scott's body started changing and his face puffed up, his spine stretched 2 inches. His immune system shifted. His gene expression altered. Yes, his DNA turned on different genes, responding to life in zero gravity. He was aging differently. But it wasn't just physical. Scott faced vision loss, mood swings, memory issues, and increased inflammation, like his body was fighting an invisible threat. Even his telomeres, the caps on his DNA linked to aging, got longer in space. Aging in reverse? Not quite. They shortened quickly once he returned to Earth. Space had pushed his biology into survival mode. When Scott landed after nearly a year, he wasn't the same. He had weakened bones, thinner skin, muscle loss, a slower metabolism, and 7% of his gene expression remained changed, even months after return. That's right. Space rewrote his body at the cellular level. NASA's twin study changed everything we knew about long-term space travel. It gave us insight into how astronauts will survive on Mars, how the human body adapts to new worlds, and how fragile yet flexible our biology really is. Scott Kelly went to space as a man. He came back a different version of himself. And his twin? Still grounded, still earthbound, a living mirror of what space can do to the human body. We don't just explore space even. Space explores us. NASA.